this video, I'm going to talk about simple titration calculations. By the end of this video, you should be able to calculate the concentration of any solution in moles per decimeter cubed if you have another solution with known concentration and volume. Here is the question. 25.0 centimeter cubed of 0.100 moles per decimeter cubed of sodium hydroxide was titrated against a solution of hydrochloric acid with a known concentration. 23.5 centimeter cubed of the acid was required to neutralize the alkaline. Calculate the concentration of the acid in moles per decimeter cubed. Step number 1, write a balanced chemical equation. 1 mole of sodium hydroxide reacts with 1 mole of HCl to produce 1 mole of sodium chloride and 1 mole of water. Start by listing everything you know about the sodium hydroxide or the HCl. I'll start with the sodium hydroxide. We know that the volume that was used for sodium hydroxide is 25 centimeter cubed. Convert into decimeter cubed by dividing by 1000, and this gives us 0.0250 decimeter cubed. The concentration of sodium hydroxide is 0.100 moles per decimeter cubed. We don't know the number of moles. For HCl, we know that 23.5 centimeter cubed was used, divided by 1000 to get the volume in decimeter cubed, which is 0.0235 decimeter cubed. We don't know the moles and we don't know the concentration. When you look at sodium hydroxide, you know the volume, you know the concentration. Use the triangle, work out the number of moles of sodium hydroxide. Or if you can recall, then the number of moles is given by concentration in moles per decimeter cubed times volume in decimeters cubed. Then you can work out the number of moles of sodium hydroxide, which is equal to 0.100 times 0.0250. And this gives us the number of moles of sodium hydroxide as 0.0025 moles. Now if you go back to the chemical equation, 1 mole of sodium hydroxide reacts with 1 mole of HCl. This means that the number of moles of sodium hydroxide is always equivalent to the number of moles of HCl. The number of moles of sodium hydroxide is equal to 0.0025 moles. Therefore, the number of moles of HCl will also be equal to 0.0025. If you look at HCl, we know the volume, which is equivalent to 0.0235 decimeter cubed. The number of moles is equal to 0.0025 moles. We can apply the triangle or recall that we can calculate the concentration using this equation where concentration is equal to the number of moles divided by the volume in decimeter cubed. If we substitute in our values, 0.0025 moles divided by 0.0235 decimeter cubed, this gives us the concentration of HCl, which is equal to 0.1064 moles per decimeter cubed.